Hi, my name is Stephen Thomas. I'm Chief Technology Officer at SMT Data, and I'm going to be giving a demo of ITBI for Z-Series. Before we go into the demo, just a few words about how the product works. ITBI is, as the name implies, a business intelligence solution for IT technical data. Today we're going to be talking about SMF data from IBM Z-Series computers. We basically take a wide variety of SMF data and read it into a SQL Server data warehouse running on a Windows server, either at the customer's location or in the cloud. We can then enrich this technical data with business information to help us understand who is using the capacity and what it costs. From this data warehouse, we generate analysis services data cubes, and then we can look at this data with the help of an advanced business intelligence reporting and analysis tool. And that's the tool that we'll be looking at in the demo. So let's go over to the demo. What we start out with is a sort of a dashboard looking at a number of sort of standard SMF types. We're going to look at some SMF type 70, 72, and 30. And what we see here is some very high-level reports over a week's worth of data from a demo database where we're simulating two LPARs. So we have a production LPAR here and a smaller test LPAR. First, let's look at some data coming from the SMF70. Now, most customers who are paying for their capacity are in one way or another paying for their peak usage during a period of time. So if we look over this week here, what we see is there's a peak Friday night. So the blue line is showing the actual MIPS utilization, and the red line showing the MIPS share limit or the weight of these LPARs. If we go down below that, based on the SMF72, we can dig into a little bit what's causing this peak. So here we see the same data, but split out based on workload. So we can see the blue is batch, the green is online, the red is system, and the black is the overhead. That is the difference between the SMF70 and 72. And already here we can see some of the first findings here. We have our peak is being driven by a batch workload Friday night, but over here, just to the right, we can see a lot of white space later on early Saturday morning. And so the question is, could some of this batch have been capped or moved out into that white space to reduce the peak and save money? Going back to the dashboard, we also see some queuing to understand a little bit about quality of service. And we can also look at the 4-hour rolling average MSU measurement. And this is very interesting for customers who are paying for their software based on the IBM workload licensing charging model. And as you probably know, this is based on the monthly peak. So let's just expand that graph to look at an entire month here, just to validate that one evening we were looking at is in fact the monthly peak and not just the weekly peak, and it is. So what's interesting to understand this peak is to dig into a little bit what's actually running during that peak. And if we go back to the 72 graph here and just select some of these hours right around the peak, and zoom into those, and then go over and look at what we see on the SMF30. On the SMF30, we can see the top 10 jobs or address spaces contributing to that peak. And here we actually get a very different picture from what we saw before when we look at the whole week, because now we're just looking at the actual cost driver for this week, which was those batch jobs running at that point in time. So that was sort of a very quick overview of some of the key SMF data that you can get and do some initial technical optimization of this system. Let's just take a step back and look at some of the enrichment of this data with business information that I mentioned earlier. So what we've done here is we've taken this same peak between Friday and Saturday, and we've taken, based on the SMF30, and mapped the individual job names out to a business area like retail banking, and then an application like NetBank. And then we can see how many MIPS each of these areas are using in total. So we can see retail banking is definitely the big contributor to our MIPS usage during this period of time. And of course, what's really interesting is to dig into the hours right around the peak that are contributing to our 4-hour rolling average MSU a peak here. So let's just zoom in on those hours, and we see, as we saw before, it's these C1C jobs that are contributing to the peak. But here we've got this expressed in business terms also, that this is the retail banking business area and the credit application that's really driving our cost for this month. And this allows us to have an intelligent dialogue with the business about, does this application need to run at this point in time? Could some of this have been pushed out into the early hours of the morning of January 31st? And how much money would we save if we were going to do that? So that was a very quick demo of ITBI for Z-Series, where we've seen both some technical information, but also how we enrich that data with some business information. If you're interested in more information about SMT data or ITBI, please visit our website, www.smtdata.com, or contact us at info@smtdata.com. Thank you very much.